right, so this week we are looking at trigonometry with right-angled triangles. The first question I want you to ask anytime that we are looking at trigonometry or triangles, the first thing I want you to always ask is it a right-angled triangle? Because there's a set of rules for right-angled triangles and there's a set of rules for non-right-angled triangles. They don't work for each other. So if you go, SOHCAHTOA, I'm going to use this, even though you get everything all, you think it's all right, but it actually wasn't a right angle triangle, all of your results will be wrong. So it's really, really important that your first question is it a right angle? Is there a right angle in this triangle? Okay, so SOHCAHTOA only works for right angle triangles. What other rule only works for right angle triangles? Pythagoras. Okay. And also that area formula for triangles where it says half base times height, you have to really have a right angle in there because it's the perpendicular height. So all of those formulas, all SOHCAHTOA, Pythagoras, and half base times height are only used for right angle triangles. We then have a different set of rules completely for triangles which don't have a right angle in them, which we'll be doing next week. Okay, so the first question is there a right angle? For any of these questions, anything with a triangle, is there a right angle? Yes, this is a set of rules. Is there no? This is a set of rules. And we'll write up a big table which will help you to remember it all before you test. Okay? So this week we're just looking at rules for right angled triangles. Now, the other thing people get mixed up with this sort of thing is that they go, oh, SOHCAHTOA, we're using all these ratios and things. You've all seen them before. It can only be in a calculator section. Now, what I'm going to do over the next couple of weeks is I'm going to make it really clear to you what questions could be in a non-calculator section. But there are definitely questions which are in a non-calculator section for this. So don't assume that everything is calculator based. Now, I've had the weirdest experience I've ever had last year in the middle of the Year 11 APPS exam at the start in the reading time for the non-calculator section, because this student from a class which wasn't my class put up their hand and I wrote the exam. I wrote the trig part of the exam, and I put up their hand and they went, I've got the wrong paper. You can't answer this without a calculator. This isn't fair. It's not right. And I said, you can. I went, you've got the right section. And they started pretty much yelling at me in the middle of the exam going, no, this can't be answered. It's not fair. And started getting really, really angry. And I was like, you can. And I just had to walk away. And about 3 or 4 people did the same sort of thing, not as intensely as this one girl. But they all went, you can't do this. You just can't. And I'm like, you can. Okay. So I will try to make it very, very clear to you what sort of questions you can get in a non-calculator section. But just like I went through all the Pythagoras triads with you and told you how many times those questions would come up in a non-calculator section, at least 50% of you either didn't answer the question or did full Pythagoras to find the answer to 2 of the triangles which were in the non-calculator section in the last test, which was 3, 4, 5, and 6, 8, 10. Or maybe it was 5, 12, 13, one of them. Okay, and I went through that with you pretty much every second lesson for a month. All right, so I can't make you remember what's going to be in a non-calculator section. All I can do is give you lots of examples. You need to take that on board. But I will try to make that really clear when something could be non-calculator and when something is calculator. But you have to actually listen and you have to take it on board, okay? And I don't want anyone yelling at me in the exam, all right? Never again. All right, so if we look at this, the first step we do, what did I say was the first step we always do with triangles? Is it a right angle? All right, the second thing we do is once we've got the checkbox, yes, it is a right angle, we need to then label the triangle. So if you just write labeling the triangle, sorry, my computer seems to have disconnected. Let me just connect it back up. So labeling the triangles. Now, this stuff I know you've done lots of times before, but I want to make sure that every single one of you understands trig at the end of this. I don't think trig is that hard. I think this is probably one of the topics which you can make up some marks in as long as you put in the effort. The questions aren't, I don't think the questions are as confusing, but also there's lots of follow through you can get as you move through, as long as you concentrate in your work. All right, so I'm going to start from the start. If you're having trouble, make sure you talk to me about it. That's right. All right, so labelling. All right, so if we have a right angle triangle, we know it's right angle, we've checked it. There's a little square in the corner. All right, we have that and we need to be able to label the different sides. What's the one side we can definitely label? The hypotenuse, okay? So the hypotenuse is this one. How do we know which one's the hypotenuse? Okay, it's opposite the right angle and it's also the longest. Now, the longest side. Now, why is it the longest side? Connects them. Why else? Okay, what I want you to think about is, okay, can everyone put their hands out just like medium length? Put your hands out, everyone, arms out. All right, have a look at the distance between your two fingers, okay, when you're making an angle here. Okay, so it's like a medium distance, yeah. If I make a bigger angle with my arms, what happens to the distance between my fingers? It gets bigger, okay? So if I make a bigger angle with my body, what happens to the opposite side? It gets longer. If I make a smaller angle between the two sides with my body, what happens to the distance between the opposite side? It gets shorter. Okay, so if we look at a right angle triangle, 90 degrees, it has a 90-degree angle. What do the other two angles have to add up to? What is going on? What do the other two angles have to add up to? They have to add up to 90, okay? So those two angles are always going to be what from that 90 degrees? They're always going to be smaller. They're going to be smaller than 90. Each of the other two angles is always going to be smaller. So the 90-degree angle is always going to be the biggest angle there. Can you see that? 90 degrees is always going to be the biggest angle in that triangle. So therefore, the opposite side is always going to be the longest side. So that's why the hypotenuse is always the longest side, because it's always opposite the biggest angle. Now, the reason why I make a big deal of this and I get you to put your arms out and stuff is, in a test question, a lot of the time they might actually just say to you, find the shortest length of this triangle, and they give you a heap of information. So find the shortest length. Rather than going, find this exact side, they're going to say, find the shortest length, and they'll give you a heap of information. Now, if they ask you for that, a lot of you then go and find every single length, which takes a heap of time. But if I say find the shortest length and you know each of the angles, which side should you be looking at? So for example, don't write this down. If I gave you a triangle, now this is a non-right angle triangle, but if I gave you a triangle and I said this is 50, this is 60, this is 70, and I said find the shortest side, which side would you be looking at? You'd want to be looking at the opposite, the shortest angle would equal the shortest side. So which one would have the longest side? Opposite the 70. Okay, it's going to have the longest side. Can you guys see that? And that's because of that same thing. Bigger the angle, the opposite side's going to be bigger. The smaller the angle, the opposite side's going to be smaller. Okay, so it makes it a lot easier for you guys to be able to work out questions like that when it says find the shortest side or find the longest side, for you to be able to just do one step instead of a lot of people do like 3 steps to find it. Is that okay with everybody? So that is the reason why the hypotenuse is the longest side, because it's opposite the biggest angle. So opposite the right angle, the longest side, because it's opposite the biggest angle. If you can remember that, it's going to really help you in a test, because it's going to save you some time and some effort. All right, so the other two sides are opposite and adjacent. Dean? Now, you can't know them without knowing one other thing. What do we need to know? We need to know at least one other angle. So you've got your right angle, but we need to know one of the other angles. And we call that, we're going to use theta, okay? You can have other Greek symbols, but theta seems to be the most common one, okay? And this is called our reference angle. It's either the angle you know, so that might say like 60 degrees in it, okay? The angle you know, or the angle you're trying to find. Okay, that's what the reference angle is. The reference angle is the angle you know or the angle you're trying to find. We need to have that to be able to label the other sides. So it's really important that you've got at least one angle involved, whether it's what you're trying to find or what you know. All right, so now I've got opposite and I've got adjacent. What does the word adjacent mean? Next to. Opposite means opposite, across from. So therefore, what do you think this bottom line is? Next to or opposite? It's opposite because it's opposite. So this side here is the opposite because it is opposite the reference angle. So both the opposite and the adjacent relate to the reference angle. So if the angle was in the other corner, the opposite and the adjacent would be at different sides as well. So you always need to know. Hypotenuse is easy. The other two always relate to whatever angle we're looking at. So where adjacent therefore has to be on this side. So the way we remember it is that it's next to the reference angle. The other way some people remember is it's between the angle and the right angle. But adjacent means next to, so it's easy to say next to the reference angle are our letters. Now, if you label things wrong, you're going to get all of this stuff wrong. Okay, there's really only three mistakes people make. They either label it wrong, they pick the wrong ratio, which we're going to go through next, or they rearrange their equation wrong. Now, all three of those things, if we do this step by step, we shouldn't make those mistakes and this should be quite easy. Okay, as long as we practice and go through it, I think all of you should be very confident in this. But it's just about taking the time to make sure you go through the steps carefully. All right, is everyone okay with labeling those? Okay, so quickly together, you don't have to write these down. Let's just do it quickly. If I look at this, that's my angle. Okay, what side is the hypotenuse? Right, left, or bottom? Right. What side is opposite? Bottom, because it's opposite the angle. Which side is adjacent? Left. Now that one's pretty easy because it was exactly the same as what I just drew. What about if we go this way? Which one is the hypotenuse? So I've got left, right, and bottom. Which one is the hypotenuse? Left. Now always do the hypotenuse first if you can, because then you don't get confused with the other two. But the other two are always around the right angle, which I should have drawn. Okay. Which one is opposite? Which one is adjacent? All right. Everyone see that? The labeling is important. Everyone good with that? All right, so let's move on to SOHCAHTOA. Now, there's a word I need you to really understand, and this word comes into those non-calculator questions as well, okay? SOHCAHTOA is a way of remembering. So it's not like a rule, it's not specifically a rule, it's a way of remembering three different trigonometry ratios. It's all it is it called a mnemonic? I think it is, okay? All it is a way of remembering three different ratios, okay? Now, it's really important that you note the word ratios, because if you see the word ratio, you need to know that SOHCAHTOA. If you see the word rule, you need to know that it's got to do with non-right angled triangles. It's killing me. Okay, so is a way of remembering three different ratios. A way of remembering Three different ratios. Sine ratio, cosine ratio, and tangent ratio. Can you write that down while I'm getting... I'm glad the lid was on that. Sorry, I think the wireless is just a bit out today. All right, so as a way of remembering three different ratios, what did I just say? What were the three ratios? Sine ratio, cosine ratio, tangent ratio. Okay, these include an angle and a fraction. Okay, so they all look the same. They've all got either sine, cosine, or tangent, an angle, and then a fraction, which is to do with the sides. They all look the same. So it's not one thing. SOHCAHTOA isn't one thing. SOHCAHTOA are three different ratios which we choose between. So we've got to be able to pick which one to use. Okay, so if we look at SOHCAHTOA, I think of them as three separate things. TOA. Okay, so which ratio do you think SOT means? Sine. Okay, so this is sine and an angle. The angle's always connected to the sine. Okay, so it's sine times by our angle equals, now it always goes in the same order. As I said, it goes an angle and then it's got a fraction. It's an equation. Okay, each of these there's three separate equations. The word ratio is to do with our fraction. So sine theta equals, and it goes in the order of O and H, O over H. It always goes first one over second one. So O would be what word? Opposite over hypotenuse. Cut would be which ratio? Cosine. Again, it's connected to the angle. Equals, and this time it still goes in the same order, A and then H. So adjacent over hypotenuse. And TOA is our tangent. Now you can use the shortened versions of these words. I'm just for this one using the whole words. After this, I'll start using the shortened ones. Tangent, angle equals O and then A opposite over adjacent. They're all in the same format. They all go either sine, cosine, or tan times by the angle equals, and the sides in the right order. So that's why SOHCAHTOA. If you get stuck, write it down. So you could write this much quicker by just writing sine O over H, cosine. Just remember the angle. People kind of forget to put the angle in. A over H, tan O over A. Okay, if you wrote that at the top of your test page, you can't really go wrong. However, you don't even need to, because your formula sheet has this whole thing written in it in words like that. Okay, so use your formula sheet if you're stuck. It's not even, it doesn't just say SOHCAHTOA, it actually says all of those words. You don't need to remember it, you just need to know how to use it. Okay? Any questions to there? All right, so we use this to be able to find either side lengths or angles. We're going to start with side lengths today. Okay, now that means, what are the three sort of unknowns in, if we look at sine theta equals O over H, what are the three things we have there? We have an angle and two sides. So we need to, if we're going to use this, we need to have either you're finding an angle and you know two sides, or you have an angle and a side and you're trying to find a side. So you need to have three things, including one unknown, to use this rule. But most of the time you have those things. So let's have a look. Let's give it a try. All right, so finding side lengths. We're going to do angles tomorrow using SOHCAHTOA. Now, steps are important. What did we say was the first step always? Okay, so is it right angled? If it's not, you can't use this rule. Doesn't work. Okay, so it is. What's our next step? Before that, label it. Label. What did someone say was the next step? Pick a rule, okay? Pick the ratio. 4, sub in, 5, solve. And I'm going to show you about how to solve the different types because there's really just 2 ways of solving. It's quite easy as you go, as long as you get used to it. All right, so e.g. Find the value of x. So we've got this. Oh. All right, first step, is it a right angle? Good. Second step, let's label the things we have. So you can label all the sides, but really what we need to know is what things we're either trying to find or what things we know. So what are we going to label? Do we know the hypotenuse? What is it? 17. And do we know what x is? Opposite. Okay, so that's important. Now, we can label this as A, but you need to know that it's not really going to be part of our equation or anything because it's just there. We're not trying to find it. We don't know it. So we don't need to worry about that. So let's just look at the things we're trying to find or the things we know. And if we look at SOHCAHTOA, this is where step 3 comes in. We've got to pick the right ratio. And so we are either know or trying to find O and H. Okay, so this one has an O and this one has an H, but only this one has both of them. So which ratio are we going to use? That one. Okay, so even if you get your highlighter out, which all of you should have in your test, write it out and go, okay, which one should I use? The only one which has both of them, O and H. So we're going to go, okay, let's write this rule out. So sine theta equals O over H. That's our rule. Is anyone stuck with how to choose the ratio? Okay, so we look at what we know and what we're trying to find and find the ratio which actually suits that. You have to have both those second letters. So once I've got this, I've picked my ratio. So my next step, step 4, is sub in. So instead of theta, I'm going to put in 36. And instead of opposite, I'm going to put in x. And instead of hypotenuse, I'm going to put in 17. Now, be aware, don't just leave it as O for opposite because the question's asked you to find the value of x. If you write O equals, you're not going to answer the question correctly. It has to be x equals, so sub in the x as well. All right, there is if the x is on the top of the fraction. So if the pronumeral is on the top of the fraction, how do we start solving this? How do we rearrange this equation? Good, we're going to move the 17. So on the top of the fraction, we move the denominator to the other side because right now it's x divided by 17. We need to just find out what x is. So anytime there's a fraction, we need to get rid of that fraction. We need to be able to go, okay, what is x? What is a 17th of x, which is what it is right now. Okay, move the denominator to the other side. Same thing every time. Now, is it going to be multiplied or divided, or what's that 17 going to happen on the other side? It's going to be multiplied. So we're going to move the 17 and we end up with 17 times sine 36 equals x. So now we're working out what x is, not what x divided by 17 is. All we need to do is put that into our calculator. Now, 17. Where do I find sine, do you think? Trig. You can actually just write sine, but we go to trig. Now, what we're going to be using is the top three, sine, cosine, tan. They are for if we're finding lengths. So today, we're just going to be using sine, cosine, and tan. If we are trying to find angles, we use inverse sine, inverse cosine, inverse tan, so the ones below it. We don't use anything on the right-hand side. All right, so, but if we're finding a side length, we just use the top three. Just going to turn the lights out so you can see the screen. Can you guys still see your pages? Can you guys still see your writing? Is that better for the screen? Yes, no? Yep. Okay. So if we're finding side lengths, we just use normal sine, cosine, tangent. The light's going to keep you awake. All right. So I'm going to write sine and 36. Enter. 99.9923. So 99.99 equals x is your answer. Now, in my last class, I put this into my calculator and you'll see we got a whole heap of random answers. Not the same. I got a negative 10.08 and I got a whole heap of different things. So why do you think I might have got a negative 10? I didn't do it the wrong way? No, I actually had it in radians, not in degrees. So you need to be aware, see in that top right-hand corner how it says degrees? If it's in radians or anything else, it's going to be wrong. Okay, so your calculator must be in degrees. So to check that, you need to go document, settings and status, and document settings, and see where it says angle. There's a few different, so you've got gradians, radians, and degrees. It needs to be in degrees. And you need to press OK. I would make it default, and that way it should be them all the time. The other thing I got was this answer here. I had the square root of 4. I'd change it to degrees at this point, and I had the square root of 40 times the square root of 5 plus 5. What do you think's wrong there? It's put it into like exact value, so it's like if you just left it as a fraction. So you need to again change your document settings to approximate to get a decimal answer. Or you can just do the control enter and it should change it as well. All right, so it needs to be in degrees, and for us, we want it to be an approximate. Everyone okay with that? I'm actually really glad that I made that mistake in my first lesson with the other class, because they're the two mistakes really all of you are going to make in a test with your calculator. They're really the only two big mistakes people make in tests about trig with calculators. So it's important that if you see a really odd answer, the first thing you do is you check your calculators in degrees. And the second thing is you go, okay, well, let's just check if it can be in an approximate value. They're pretty much the only mistakes you'll make. Marnie, do you need help? Degrees. So you need to go to document settings to change your angles to degrees. Must be in degrees. Everyone okay with that? All right, so we've got 9.99. Everyone good for that question? All right, we're going to do one more example here, and then we're going to try the harder non-calculator question. So that was A. Let's try B. All right, I've got 12 meters, x meters, and 51 degrees. What's the first step? Before that, is it a right angle? Yes. I know it sounds silly now because we're just doing right angle triangles, but when we get to the non-right angle triangles and the mixed up ones, it's really important you just get in the habit of checking. Is it a right angle? Yes. Labeling it. So what's the 12 going to be labeled as? Opposite. And what's the x? Adjacent. So if we've got SOHCAHTOA, Which one of the three has opposite and adjacent? Tan, so TOA. Okay, that means we're going to use that as our rule. So we've got tan, it's always the same format, tan angle equals opposite over adjacent. Goes in the same order, OA. What do I do now? Sub in. So tan 51 equals 12 over x. Now this time it's in a bit of a different format to last time. This time the pronumeral is on the bottom. So if the pronumeral is on the bottom, let's use our algebra skills. Now for both of these you could just go solve. You could just go solve that whole equation, comma x, and it will work as well. All right? But let's have a think about this. The x is on the bottom. We can't do anything when there's a fraction with a pronumeral in it. We can't get x by itself when it's in the middle of a fraction. So we have to get rid of that fraction. So what do we have to get rid of? What have we got to move first? Can I move the 12? Can I move the 12? No, because it's being divided by x. So it's not 12 right now, it's 12 divided by a number. So I need to go, okay, I need to get rid of that, divide by, to be able to get these numbers on their own. So how do I move this x? I'm going to times by x on both sides. So I'm going to go x. Now you don't usually have to do this step because we're going to work out a little rule, but this is why it works. So times by x on both sides, so I end up with x times tan 51 equals 12. I've now gotten rid of the fraction. One of our rules when we were doing algebra was always get rid of the fraction as soon as you can. Now we need to get x by itself on one side. So what have we got to get rid of? We've got to get rid of this tan 51. So the first time we had to move the x, this time we've got to move the tan 51. It's being times by the x, so what does it become on the other side? Marnie, I know you're talking about maths, but I need you to focus here because you're going to miss the next thing. So I've got x times tan 51. So we're going to move the times by tan 51. What does it become on the other side? Divide. Okay, so x equals 12 over tan 51. I've now got x by itself. What you'll notice is we've kind of actually just switched the x and the tan 51, and you are quite welcome to go straight to that step because that's the step every single time. If the pronumeral is on the bottom, switch it with the angle and the ratio. So you can go straight to this step. So if the pronumeral is on the bottom, switch it with the angle and ratio. It will always work. But that is actually the algebraic process we go to get there. No, so you can go straight. You need this line here will give you a working out mark. You can go straight to x equals and an answer if you want to, because you can do that as a solve, or you can do the rearrange bit as well. The line which of working out you must show is at least this one. If you don't show that one, you need to show the bottom one. All right, has someone put that in their calculator for me? 12 over tan 51? 9.71 metres is your answer. Any questions? You don't actually have to write metres for that one because metres is next to the x already, but it's okay. Do you guys think you can do that? Where most people go wrong is that they try and switch the 12 over, or they try and somehow move the top of the fraction. You can't move, if something is being divided by something else, you can't move it until you get rid of that dividing bit. Okay, so you can't move the top of a fraction ever until you've gotten rid of the bottom of the fraction. That's probably the one mistake people really make in this in their working out. Do you guys all feel like you'll be able to find sides? Okay, one last bit, non-calculator. Finding ratios. This could easily be in a non-calculator section. Now, ratios just mean the fractions with the sine or the cosine rules. okay? Or the tangent rules as well. I'll give you an example of what I mean by this. E.g., for the following, and this is where lots of people go wrong in a test, even though it's quite easy. I'm going to give you a triangle which gives you lots of different bits of information. 5 metres, 4 metres, 3 metres. We know that's a right angle triangle because it is 3, 4, 5. And I'm not going to give you any of the angles. I'm just going to label them with a letter. Can we actually find out what those angles are? We can if we use this, okay? Without a calculator though, we can't. So in a non-calculator section, I'm not going to ask you to solve what something is. I'm going to ask you to find a ratio. So for example, I'm going to ask you a question like this. For the following, find the ratio of sine A. That's going to be the question. Find the ratio of sine A. And suddenly in a test, everyone goes, what? I don't understand. I don't have a calculator. How can I do this? It's not asking you for the value of A. It's asking you for the ratio of sine A. So what this is saying is, it's saying if A is the reference angle, find the sine ratio equation. That's all it's saying. It's not saying you have to find an answer in your calculator. It's saying if A is the reference angle, because remember how I said the angle is always connected to the sine, the tangent, or the cosine? Okay, this is labelled as A. It's saying what's sine A? If A is the reference angle, what is the equation with sine in it and A is the angle? So all we need to do is work out what the different, if A is our reference angle, what are the different side lengths? What would 5 be? Hypotenuse? What would the 3 be? And what would the 4 be? Adjacent. So because it's A is the angle, we've got A, O, and H. Now, we're saying sine A equals, now SOHCAHTOA, sine, S-O-H. So we're saying equals O over H. So therefore sine A equals, opposite is 3, H is, that's your answer. It's just asked you for sine A. Sine A is a ratio. What's the ratio? Sine A equals 3 over 5. Because when we've used A as our reference angle and we've labelled the sides, sine is O over H. We've found the opposite, we've found the hypotenuse, and we've written it, and we just leave it like that. That's it. It hasn't asked you for an answer, it's asked you for a ratio. Can everybody see that? So it's actually really easy once you get the hang of it. It's just hard to start with. All right, so what if I asked you to find tan C as our question? What's our reference angle going to be? C. So now I have to relabel it. H is still H. But this time, if reference angle C, what's the 4 become? Opposite. And so therefore, the 3 becomes adjacent. And so if I'm trying to find tan C, tan is TOA. So tan C equals opposite over adjacent. So tan C equals, the opposite to C is 4, and the adjacent to C is 3, and that's your answer. So you may have to relabel the same picture, which is where highlighting can help. Or just redraw the picture for yourself. Any questions? I need you to try and practice these. Now, I'm not sure how much time we've got. I think you've got about 5 minutes. What I would like you to do is get started on the questions, which I'll put on the board in a second. It's in book 2. I do need you to get these done. So we don't have class tomorrow. So you've got 2 nights to get this done, because tomorrow Wednesday we're going straight into angles, and you need to have a really good understanding of this first. So it's exercise 10A in book 2. Now it's questions. I think it's 4, 6. Hang on, I'll just check the other class. 4, 6, and 9 to 17. Questions 4, 6. Now there's some different parts to that. And then 9 to 17, they're all just separate triangles. So there's just one triangle for 9, one triangle for 10, one triangle for 11, and so on. So I reckon if you've got a few minutes, you should be able to get most of this done in class right now. So everybody should be working as hard as they can in the next 5 or so minutes. Quickly. If you're having trouble with the working out in particular, make sure you come and see me, or I'll come round in a second.